Okay. Now the next question that we got on the menu is how do we find the angular velocity? So first we got to talk about what angles are and what angular velocity is. So, you know, here, let's say, here we have like theta. That would be our angle. Now let's say, you know, you're a windmill and the windmill is turning. The angle at which one of those windmill arms is always going to change. So the angular velocity is rate of change of the angle. Okay, now to get the rate of change of an angle, well, we just do a derivative. So angular velocity, we represent it with the Greek letter omega. I know it looks like a W. It is not a W, it's omega. Omega. And this is just the time derivative, d over dt, of theta. Okay, and yeah, that's exactly how you find the angular velocity. If you know how its angular position changes with respect to time, well, take the derivative of the angular position with respect to time and you'll get your omega term, which is your angular velocity. Another way that you can calculate your angular velocity is, let's say you only know the linear velocity. Linear v to angular v. Okay, suppose you're driving in a roundabout like this. And this is you, your rectangle car, and your velocity here. Here you have r. If you increase your velocity, you should expect your linear velocity. That's what you would see on your speedometer. So if you're driving like kind of slow in a roundabout, as you should, you know, your angular velocity is good. But if you're really speeding it up, and you're really hitting the gas and you're going 100 kilometers per hour in a roundabout, like you'd have a very fast angular velocity. But if r gets bigger, you would expect to see a smaller angular velocity if you maintain the same linear velocity, because you have a bigger circle to get around. So the actual angle that you're changing is going to be smaller for the amount of distance that you're covering. So the actual equation is v over r. So linear v is equal to u. This is radius. And that's equal to omega. Okay? And the units perfectly work out. Like linear velocity would be something like meters per second. R would just be meters. So all you'd have left is like meters per meter second, which is the same as radians per second. Okay, so this is just another way to find the linear velocity, or to find the angular velocity if you're given the linear velocity. If you're traveling at a constant velocity in a circle, divide your linear velocity by the radius of the circle, and that's how you get your angular velocity. Yep, it's fairly straightforward. But it's got to be a constant, because like your linear and your angular velocities, if they change, well, you know, it's only, your calculation is only going to be right sometimes, you know, so it's better if they're constant. So yeah, the above solution is good. Okay, so I think that was the last question. And yeah, time flies when you're having a fun physics time. Alright, cool. So, you know, those are all the questions for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and ring the notification bell below. If you'd like to submit your own questions, also visit the links in the description below. Remember to leave a like if you liked the video, and leave comments about your thoughts on all this fun physics. Share this video with your friends if you really enjoyed it. And this has been Millen from OneClass. I hope to see you again soon. Take care. Have a great day. And remember, physics will never betray you. Okay, well.